So guys, I don't mean to interrupt, but we're going to Mark Sokol now. Mark is coming on. So
Yeah, but bring on Mark. I want to hear from Mark. We want
Hey
Mark.
guys,
We want Mark.
there we go. There
Hi,
we
Mark.
go.
there
I
we go.
got
Well, here I am, and here's
Okay.
the setup. So everything that I promised you regarding the Elzaphan experiment, we're going to have different views inside the chamber. We're going to have thermal imaging. All of that is set up right now. I'm just trying to get the analog scale set up right now. That's what you saw me doing inside the Faraday cage recently. You can see here we got 3 different views. One camera is from the top of the chamber. This one is looking, the one to the left of me is looking at the analog scale. The one in the top right corner, you'll see like a pale digitized sort of image. That's a fiberscope view inside of the waveguide. We're going to be sticking a sample in there. I hope to get this done in the next half hour or so. So if you guys stick around, I'll be working on this, and we'll try to get some sort of experiment set up. Wayne Ojala had some interesting results over the past 2 weeks, working with much lower power, using a non-homogeneous magnetic field. He was just using a standard puck magnet, and with some oxides, he was able to get a constant weight loss. It was consistent. You turn it on, it would drop in weight over time, and then you turn it off, the weight would come back. So we're pretty excited about this experiment. We got lots of samples to run. This is not going to be a short duration project. This isn't just push button. There's you have to change samples every time.
So Mark, if I could jump in real quick. So and actually it looks like, yeah, I see all 3 cameras now. Okay, your bandwidth looks like it's kind of coming in and going out a little bit. But so can you walk people through the experimental setup? Is that because part of it is self-serving, because you've done really short updates for the last few weeks. So I want to get some real Mark time in while you're setting people up and walking people through this. I mean, like for instance, you keep adding equipment to your lab, you keep refining things, you keep building things out, and I don't see a whole lot of that. So
well, what we're doing here is the Elzaphan experiment. This is dynamic nuclear orientation. We're trying to orient subatomic particles in the core of an atom using a process called EPR, electron paramagnetic resonance. This is similar to nuclear magnetic resonance, which we do in an MRI machine. But instead of shaking the entire atom as a whole, we're shaking just the outer electrons, and we're hitting them at their Larmor precession, which is the frequency of the axes, the rotation of the axes, which happens billions of times per second, dependent on the strength of the magnetic field that the sample is stuck in. So it's important to have the sample inside of a homogeneous magnetic field, which is why we have this massive electromagnet that you're looking down into with this picture over here. Let me see if we could just here you can see it a little better right now. So this is an overhead view of the electromagnet. We have the RF is coming into the Faraday cage on the right over here, and going through several waveguides and entering this copper chamber where all the experimentation is going to be taking place. There's a thin wire, you can just about see it on the right. That is a thermal imaging sensor that goes to around halfway down the chamber, and it's looking in to measure the temperature of the sample as we're running this experiment. The first time we ran the experiment, the sample got so hot so quickly that it melted the plastic, the PETG sample holding system. So before we were able to get any like positive results, we were already melted, the entire system, and there was smoke coming out of it. So it's important to get a thermal image of what's going on. Then you could just about make out, you see this, it's like a yellowish color. That's clay that's at the end of our analog scale. the other end of the analog scale is over here on the left, and we're just going to be looking at those two little lines, see if there's any movement on them as the experiment goes on. There's also the fibroscope is also going inside the chamber. It's about on the right hand side. It's where it's set up, and if there's any movement of the sample, we'll be able to see that as well. We're not going to be looking down into the chamber the way we are now while the experiment's going on, because there will be a cover on top of the chamber, so we won't be able to see inside it with these GoPro cameras. We'll have to look at the fibroscope to get an idea what's going on. If this experiment works, it will explain how flying saucers operate and allow for actually building prototypes and doing those 90-degree turns at 10,000 miles an hour that everyone's so excited about. Yeah, so stay tuned. I can't really talk and work at the same time because there's lots of rooms that I'm going in between. So you guys just continue on with the open discussion. And if I'm ready to run anything anytime soon, I'll unmute myself and try to get everyone's attention.